set notation and Venn diagrams. Let's make sure we can look at a Venn diagram, identify the correct regions, I understand the correct set notation, and then if they give us a shaded region, we can identify what region it is. It's actually quite simple, so let's just blast through it. I'll give you this random Venn diagram, I think with the numbers 1 to 10, and I'll put them in random places. It says write down the elements of this. This is the Greek symbol xi, we would say in the Western world, well, excluding Greece, because I think the Greeks say ksi or ksi. So this just means the universal set. The universal set, meaning all the numbers inside the Venn diagram. Now, you don't have to put all the numbers in order, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is all the numbers 7, 8, 9, 10. A and B, so this is the Greek symbol, well, the set notation symbol for intersection. I like to think of it as and, like this. A and B together, we're looking at the overlap, which is 4 and 10. 4, 10. This is A or B. This stands for union. Union. Union means all together. All together, we are friends. Together, we are one. So A or B means all the things in A, which I need to label here, all things in A or B, and also including the intersection. So that's just 2. So here I'm not going to put in order. We have 2, 5, 4, 10, 7, and 8. This one, A dash, just means not A. Sometimes you might see as A complement. So all that means is everything that is not in A. So you can basically put your hand over A and write down all the numbers that you see. So I see 1, I'm just going to do these ones first. 1, 3, 6, 9, and then 7 and 8. This is where students start to make mistakes. A, not A, and B. And then we're going to do not A or B. I'm going to kill 2 birds with 1 stone. Not literally. We don't want to do that. So I'm going to show you guys how to identify the correct regions here, because students get this wrong all the time. All right, so if you're ever unsure, just do a cheeky sketch. We're going to need some colors for this one. With one single sketch, we can actually do both of these. So let me get prepared with some colors. So you draw the diagram again. So here's your A, here's your B. And you're going to shade each one of these. So I'm going to shade not A with 1 stroke. So with red, I'm going to do not A. So I'm going to do a diagonal line everywhere outside of A. Okay, so you can see A is the only thing that's not shaded. So not A is everything on the outside. Then, with another stroke, we're going to shade B. Okay, I'm going to shade B with blue. I got different colors, but you guys could do, just a different diagonal in it. So here's B. Now, if it's and, you're looking for the intersection. Okay, you're looking for that crossover. You can see that's here. Okay, so for this, the elements in the crossover is just 7 and 8. This, or, remember, it just means together we are one. Anything shaded is what we're interested in for the or, which is basically everything apart from 2 and 5. Okay, so we want 1, 3, 6, 9, 1, 3, 6, 9, 4 and 10, and 7 and 8. There's your answers. Okay, so that's how we do that one. What about not A and not B? Now I'm wondering if I can edit my diagram slightly to not have to draw again. But we've done that one. Let's take a look, because we're still doing not A, which was in red. The problem would be this one. Not B would be everything on the outside of B. Oh, I'm going to have to do it again. Okay, so it doesn't take very long. We've got A, B, rectangle. Okay, so this shade, not A again. So that's everything on the outside of A. Then we're going to shade everything on the outside of B. So you have to be careful here on the outside of B. Okay, so remember, for and, we're looking for the crossover. The crossover is on the outside only. So not A and not B is the things on the outside, 1, 3, 6, 9. Not A or not B is anything shaded. We can see anything shaded is everything apart from the middle. So you actually want to do every single number apart from 4 and 10. 1, 2, 3, not 4, 5, 6, 7, 8, 9, and not 10. Okay, so everything apart from 4 and 10. And that's it. That's a really nice way for you guys to identify the regions that we're interested in. All right. Next thing is what is meant by circle with line through it. That just means the empty set. Okay, it just means nothing's in there. In this context, there's no region. That is the empty set. Okay. What does this mean? You see this quite a lot. Sometimes we have a double dot there. This just means the set such that, well, the set of numbers x such that x is an element of the natural numbers. So this is the set notation for the different types of numbers. Z would be the integers. You have Q for the rational numbers, R for the real numbers, C for the complex numbers. But it's also saying that x cannot equal 3. So sometimes they ask you guys to write your answer in set notation. Here's how you could describe your x values. Last thing we need to do is what regions are shaded. Okay, so here we can see that A is basically shaded, apart from this overlap. Okay. Now what some students do is they overcomplicate it. They say they have A, but we don't want this overlap between B and C. Okay, and they say A and B and C not. Okay, they're saying we want A and we don't want B and C. However, we could do this much easier and say, look, we don't want this overlap, yeah, but you could just say we don't want C. It says the same thing. So if I just remove this and say A and not C, it's the exact same thing. Okay, so you could check it. If you were to shade in A everywhere, then you were to shade in not C, the overlap would be here. So this one, the easiest way to represent this is A and not C. How about this one? Well, you can see that it's A and B, but we don't want this middle bit. Okay, so there's different ways you could say this. You could say, look, we want A and B and not the middle bit. Now, the middle bit is A and B and C, right? So you could say, I want A and B, and I don't want A and B and C. Okay, but that just looks horrible, right? Is there a way we can do this in a simpler way? Well, could we say, instead of saying A and B and C, because I already want A, could I just say not B and C? Would that work? So if I was to just remove this and say not B and C, yeah, that works. But again, I don't like the fact that I have B twice here. Could I just get away with saying and not C? Maybe. Let's have a look. So if I was to just get rid of this and say I want A and B and I want nothing to do with C, would that work? Well, again, you could do a shading where we're saying we want A and B. This section here is the only part that's shared with C. So yeah, getting rid of that, it works. So this is the simplest way of representing this one. Okay, last one here. We have A shaded again, but now we definitely don't want that middle bit. And we can see it's being shared with C. This one here, C definitely was not being used. Here, C was definitely not being used. You could just focus on the totality of the circle. Here, we can't do that. So we do have A, and we want to get rid of this middle bit. Now, again, you could say not A and B and C, but we want to simplify it as much as possible. You could just say, we don't want this overlap. So we just use the letters once. And I don't want B and C. And that is a clean answer. So this in general, guys, is how we deal with set notation. It's just like a brief overview for you guys. This trick here is probably the most important, which you'll see further on in our study notes. But guys, if you like the video today, hit the thumbs up, subscribe for more maths content, and feel free to check out all my other socials, and I'll see you in the next video. Nice.